In this video, we will study about the absolute value of real numbers and the corresponding theorems of absolute value. And the next topic is the completeness property of real numbers. So, how we define the absolute value of real numbers. Suppose that we have a real number x. Suppose that x be a real number, then the absolute value of x, which is also called the modulus of x, is defined like this. It is denoted by mod of x, and it is defined here. The mod of x is equal to x if x is a positive number or if x is 0, and if the term in the modulus sign is negative, if x is negative, then the mod of x is equal to minus x. I will explain it. So, if x is a positive number or if it is 0, if x is a positive number or if it is 0, then the absolute value of this x will be the same number inside this value, this absolute value. If x is any number greater than 0 or equal to 0, then the return of this value will be the same number x. For example, if you choose mod of a positive number, for example 3. For example 3. Then according to this definition, if the number inside the mod sign is greater than or equal to 0, then the same number is returned. For example, this is 3, and we know that this 3 is greater than 0. Therefore, the same number 3 would be returned. If, for example, it is 5, mod of 5. According to this definition, if the number inside the mod sign, the number is greater than 0, then the same number is returned, which means that we will simply write 5. Next, if the number inside the modulus sign is less than 0, which means that if the number inside the modulus sign is negative, less than 0 means negative, then that number inside the modulus is multiplied by a negative sign. It means that if the number is inside the modulus sign is minus 3. What's minus 3? Minus 3 is less than 0. Minus 3 is less than 0. We know that minus 3 is negative, it is less than 0. So according to this definition of modulus, if x is less than 0, then its modulus is equal to negative times of that number. Negative time of that number. That number is minus 3. Negative times of that number, negative 3. This comes out to be 3. Therefore, if there is a number negative inside the modulus sign, then that number is multiplied by minus, so that the absolute value of this negative number is always a positive number. So if we summarize it, the modulus of x is the same number x if it is any number greater than or equal to 0, and it is negative of x if it means that the number is multiplied by minus if the number itself is less than 0 or if it is negative. Also, according to this definition, if x is greater than or equal to 0, means that x is greater than or equal to 0. If we take x equal to 0, then according to this definition, the same number is returned. The same number inside the modulus is returned. Therefore, the mod of 0 is 0 according to this definition. I think that it is a little bit clear to you that what do we understand from the absolute value of a real number. On page number 4, next are the theorems of absolute value. The first theorem is that if you take any two real numbers x and y, then they are member of set of real numbers, then mod of x is equal to 0 if and only if x is 0. It is very simple to prove. I will explain it on my notebook. To prove this theorem, mod of x equal to 0 if and only if x is equal to 0, you will have to write down the definition of mod of x down here. You will have to write down the definition of mod of x and all the definition that we have studied. Then you will say, suppose that x is equal to 0. You have to first suppose that x equal to 0, and then you will prove that mod of x equal to 0. Now, if x is 0, then according to this definition, if x is 0, then its modulus, its absolute value of 0 is again 0. Suppose x equal to 0, then by definition, mod of 0 equal to 0. This implies that x equal to 0, 0 is equal to x. Therefore, we can replace here x. Mod of x is equal to 0. What we did here, according to the definition, if the number inside the modulus, is equal to 0, then the answer is 0. I explained it here. Then the answer is 0. I write it here. Mod of 0 is equal to 0. This implies that since x is equal to 0, I can replace this 0 by x. I did just here. I replaced this 0 by x here, and I proved this. Now, since it is written if and only if means that you have to suppose it, and you will prove this. And conversely, you will suppose this, and you will prove this. I firstly supposed this and proved this. Now I will suppose that mod of x is equal to 0, and I will prove that x equal to 0. Now you conversely suppose that mod of x is equal to 0. Conversely, suppose mod of x is equal to 0, then according to the definition, watch out the definition. If x is greater than or equal to 0, two cases are there. If x is greater than 0 or if x is equal to 0, then this mod of x will return the same x, which will return the same x. It means that since our x is equal, since this mod of x is equal to 0. This answer is 0. Then according to the definition, mod of x is equal to x. I will explain it again. You conversely suppose that mod of x is equal to 0. It means that the absolute value, the answer of absolute value is 0. And we have studied in this definition that the answer of the absolute value is the same number x. It is only in the case if x is greater than or equal to 0. Okay, then according to this idea, if mod of x equal to 0, then answer is because the 0. Therefore, it means that its absolute value of x is the same number x. Now, since mod of x is equal to 0, we will write down it here. Since mod of x equal to 0, this implies, this equation will imply that mod of x equal to 0, then 0 mod of x, replace mod of x by 0 equal to x. This implies that x equal to 0. Now we have proved that if x equal to 0, then mod of x is 0, and conversely we proved that x equal to 0 when mod of x equal to 0. Hence x equal to 0 mod of x is equal to 0. Mod of x is equal to 0 if and only if x equal to 0. The second part of this theorem is mod of minus x is equal to x for all x member of real numbers. So to prove this, mod of minus x is equal to mod of x, we have to consider three cases. First, that if x equal to 0, then mod of minus x is equal to mod of, because x equal to 0, so mod of minus x is equal to minus 0. And what is minus 0? Minus 0 is 0. Therefore, I can replace minus 0 by 0, mod of 0. And since x equal to 0, I can replace 0 by x. This comes out to be x. Okay. This implies that mod of minus x is equal to mod of x. Is equal to mod of x. In the next, we'll suppose that next case is if x is positive, which is greater than 0. If x is greater than 0, then minus x is obviously less than 0. It is negative. Since x is positive, so a positive number multiplied by negative is negative, means it is less than 0. Now, mod of minus x is equal to, what does it mean? Since minus into x is positive, so minus x is negative. According to the definition, if x is negative, If x is negative, then the returning value is minus x. We know that this whole number is a negative number. Therefore, according to the definition of absolute value, this number is multiplied by minus, and it comes out to be plus x. So the uh, the returning value of mod of minus x is equal to x, because I repeat it, if x is greater than 0, then minus x is less than 0. Then the absolute value of this minus x, because minus x is less than 0 means it is negative, then according to absolute value definition, the modulus of negative of x is equal to minus times that number, that negative number. It comes out to be a positive number x. We know that x is positive. We know that x is positive. Therefore, according to the definition of absolute value, if x is positive, then x is equal to mod of x. Mod of x is equal to x, or x is equal to mod of x. We know that here x is positive, therefore this value x is equal to mod of x. The reason is that x is greater than 0, and we applied the definition of modulus. This means that mod of minus x is equal to mod of x. This means that mod of minus x is equal to mod of x. Now in the final case, you will suppose that x is negative. If x is negative, then minus x. Since x is negative, this negative number multiplied by this negative, it is positive. Now since it is positive, then by definition, mod of minus x, because this minus x is greater than 0, it is positive. Then if the number inside the modulus is positive, then according to the definition, the same number is returned. Okay, according to the definition. For example, if the number inside the modulus is a positive number 5, then the same number 5 is returned, which means that because x is negative, so minus x is positive, and we know that if we take the modulus of a positive number, then the same positive number is returned, like the case here. Since x is negative, minus x is positive, therefore the same positive number is returned. Okay, and we know that minus x is positive. If it is positive, then if minus x is negative, then it means that minus x is positive. It is positive. Then since x is less than 0, x is negative, so according to the definition, this quantity equal to mod of x. I explain it. According to the definition of absolute value, mod of x is equal to negative x if x is less than 0. Since in this case we have x less than 0, therefore this minus x is equal to mod of x, as in the case here. Okay, this implies that we again have mod of minus x is equal to mod of x. Hence in all these cases, mod of minus x is equal to mod of x, and we have proved it. The third, we have to prove that mod of xy is equal to mod of x multiplied by mod of y for all x and y. Both x and y are real numbers. So thirdly, we have to suppose that mod of xy is equal to mod of x multiplied by mod of y for all xy member of set of real numbers. For this, you will suppose that x and y both are positive. You will suppose that x and y both are positive. Which means that if x and y are both positive, then xy is positive. Their product is also positive. If xy is positive, then what about the mod of xy? We know that if the number inside the mod is positive, then the same number is returned, xy. So if the number inside the mod sign is positive, then the same number is the answer of this absolute value. So the mod of xy is xy because xy is positive. Why is it is positive? Because x is positive and y is positive. Now we have supposed that x is positive and y is positive. Since x is positive, then according to the absolute value definition, mod of x is equal to x if x is positive or 0. Since x is positive, therefore mod of x is equal to x. So I will write this x equal to mod of x. Since y is greater than 0, then according to the definition, mod of y is equal to y. Okay, it is clear to you. Now this implies that mod of xy is equal to mod of x multiplied by mod of y. Clear? Now suppose that x is negative and y is negative. These both are negative. If they both are negative, then their product is positive. X is negative and y is negative. Minus minus plus. It means that this product is positive. If it is positive, then the absolute value of this positive number is again that number. Now I cannot write it in the same way like this, because I will have to write it first. Minus x into minus y. I can write it xy. I can write xy equal to minus x multiplied by minus y. Now, according to absolute value definition, since x is negative, then according to absolute value, mod of x equal to minus x if x is less than 0. Since x is less than 0, so minus x is equal to mod of x. So I will write this minus x is equal to mod of x. And similarly, this minus y equal to mod of y. So from here, mod of xy is equal to mod of x is equal to mod of x. Mod of xy is equal to mod of x into mod of y. Clear? From these two explanations, we have seen that if x and y have same signs, then mod of xy is equal to mod of x into mod of y. If they have, means that they are positive, or if they are negative. If they are positive and they both are negative, then mod of xy is equal to mod of x into mod of y. Now I will suppose that x and y have opposite signs. Suppose that x and y have, now if x and y have opposite signs, suppose x is greater than 0 and y is negative. X is positive and y is negative, then their product, one number is positive, one number is negative, then their product must be a negative number. Now xy is negative, so according to the definition, since xy is negative, we know that if the number inside the mod is negative, if xy is negative, if the number inside the mod is negative, then we know that according to the definition, this number is multiplied by negative sign, right? I can write it in the form x multiplied by minus y, because I want to use the value of the absolute value, and we have supposed that y is negative, therefore I will use it with negative. Since x is positive, since x is positive, then according to the definition, if x is positive, then mod of x is equal to x. If x is negative, then mod of x is equal to negative x. In this case, since x is positive, I can simply write it x is positive, then its mod of x is x. And since y is negative, therefore mod of y is equal to minus y. I can replace minus y with mod of y because y is negative. Okay, in this case, we have proved that this implies that mod of xy is equal to mod of x into mod of y, and from all these cases we have proved that mod of xy is equal to mod of x into mod of y, and it completes the proof.